So next up, we have Javier Luraschi from RStudio. Thank you very much. Join me in welcoming him.
Thank you, everyone. Today I'm really excited because we're going to be talking about three things. We're going to be talking about Spark, MLflow, and a new project called Delta Lake. So we're going to get started. It's going to go fast. So what about Spark? If you've never heard about Spark, this is what you need to know. Mostly, there's a lot of data in this world. The World Bank reports that actually data is growing exponentially. Basically, around every 2 years, you can expect that we have twice as much data. And what do you do when you have a lot of data? Well, you can try a lot of things, like first of all, sampling your data sets, using tools like Arrow, getting a bigger machine, lots of different things. But when all fails, what you can do is split your data into multiple machines. And you can do that with something called Hadoop, which was a very popular tool for many years. But if you want to even provide better performance and much more functionality, a better replacement for Hadoop, the runtime, is Apache Spark. So that's kind of like the intro. If you want to use Spark on R, like what do you do? Is well, you use the Sparkly R package. And the great thing about the Sparkly R package is that if you're already familiar with dplyr, you can basically reuse all your dplyr code and then add a couple lines on top of it and read the data in a distributed fashion and still use dplyr to scale your data sets. So that's pretty great. And it also works in a similar way with packages like Broom, Erlang expressions, and DBI. So how exactly do you use Sparkly R? Well, first of all, if you don't have a cluster with a bunch of machines and a bunch of budget, don't worry. All you need to do is run Spark install, and that's basically going to install a local version of Spark in your local machine. And then you use Spark Connect to connect to the cluster, either locally, or if you happen to have like Yarn, Mesos, Kubernetes, or whatever, you change the master parameter to the location of your cluster. Then you can read and write data, on CSV file formats. Parquet from Arrow is a great way of interoperating. Avro, JSON, and a bunch of others like databases. You can also do data analysis with tools that you already know and love, like SQL using the DBI package or dplyr. And you can run over 50 machine learning algorithms and feature transformers using the MLleaf library, which is provided by default on Spark. You can also grab those models and extract them out in a pipeline, and then you can use those pipelines in production or push them to Python or Java-enabled devices. And you can also build extensions. We can't obviously provide support for all the functionality that you might want. So you can write extensions for Spark and R in Scala, or you can also use R extensions using Spark Apply. And last but not least, one of the latest features added to Spark was Spark Structured Streaming, which basically allows you to process real-time data sets in Spark with the same set of functions and also using things like dplyr. All right, so what have we been up to? Well, we started the Sparkly R project back in 2016. And since then, we've obviously added a bunch of features, but I think it's more interesting to highlight that there's a bunch of products and cloud services that have embraced Sparkly R. At different degrees, some of them have provided blog posts and documentation on how to use it. Some other cloud providers like Databricks and Qubole have actually added first-class support in Sparkly R for their clusters, which is pretty great. The last release of Spark was Spark 1.0, where we added support for Apache Arrow. And yes, we did got 40 times performance improvements, as Neil was mentioning. So that's pretty great. It's still optional, so you don't get Arrow by default. You need to install the Arrow package and then use it. And Sparkly Arrow 1 also added support for XGBoost, Broom, and TF records. The talk today is more about Sparkly R 101, which we just released to CRAN. And one of the new features that Sparkly R 101 adds is support for Delta Lake. So what is Delta Lake? Delta Lake is a new open source project which happens to be hosted with the Linux Foundation. And what it adds, it gives Spark the ability to have ACID transactions, which is basically database-like properties to use on top of your data lake. Now, this doesn't mean that you should use this doesn't mean that you should replace your databases with Spark. That's not at all the goal of this project. But what it really allows you to do is to mix real-time data with batch processing data on the same table. So in the past RStudio conference, I had to do this demo where we use different types of functions and to load data, streaming data against batch data. And basically, you can replace all that with Delta Lake because you don't need to worry about where the data is coming from. It just goes to the same source. And it also enables a few nice features, like being able to find and use previous versions of your data set, which we'll see in a second. So how do you use Delta Lake from R? You need to load the Sparkly R package, and then you connect as usual. But there's a new parameter called packages. So you want to specify packages equals Delta. And then you basically use the functions to read and write data. You say Spark write Delta, and you write a data frame. Here we have a huge data frames with 3 rows. And we're replacing that huge data frame with another data frame with 1 row. And basically, then if you ask Delta Lake for that particular data set, you just say Spark read Delta, and you get that data set, right, with 1 row. But what is interesting is you can also tell Delta, hey, give me the previous version that I just overwrote. And what that would give you back is the 3 records that were initially there. All right, so more new features in Sparkly R 101. Well, first of all, these are community extensions. So super exciting to see the community growing and building extensions on top of Sparkly R. There's 2 extensions on the genomic space. So if you're into genomics, there's one called Variant Spark for doing genome-wide association studies, and one initial extension for using Hail from Spark, which is currently in CRAN, but still probably still needs a few more releases to be fully usable. And there's another extension called Spark NLP. If you're into natural language processing, that's an extension that you want to check out. And you can take a look at all the extensions, or at least some of them, under a new GitHub repo. It's github.com/rspark. A few more features on Sparkly R 101. Qubole is, as I mentioned, added support for Sparkly R on their clusters. So if you happen to be a customer of Qubole, in order to use Sparkly R from those clusters, all you need to say is Spark Connect method equals Qubole. For those of you using Databricks, this is very similar to what we already have, which is to connect to Databricks, you would say method equals Databricks. And that's pretty much it. It's quite simple and straightforward. There's also Spark 3.0 about to be released at some point this year. It's currently on preview, so that means that you don't want to use it for production. But basically, if you can't wait to try it out, or you have workflows that you're planning to move to Spark 3.0, this is a great way of trying it out. It adds new features like support for Java 11, GPU scheduling, and also binary files. So how do you use it from Sparkly R? Well, what you would do is basically you want to say Spark install and then 3.0 preview, and that installs the 3.0 version, the preview version of 3.0 in your local machine, and then you just connect to Spark 3.0. We have a long tail of bugs, so it's definitely, if you find issues, let us know and we'll fix them. And in this particular example, what we're doing is we're downloading ImageNet, well, actually a subset of ImageNet called Tiny ImageNet. And we're using the pins package to download it, and then we're loading that data set into Spark by using a new feature called binary file, which basically gives you a data frame with images in each row, which you can use for deep learning or why not. And this brings me to the last feature, which is pretty geeky, but I'm really excited about it. So one of the new kind of like trends that the Spark community has been noticing is that if you look at the state-of-the-art deep learning models, a lot of them, several years ago, they all were trained with a single GPU. But if you look at newer models like AlphaGo or the OpenAI's V1V or whatever it's called, 1v1 model, they all use more than one GPU to get trained. And Spark, trying to be this platform that allows you to run distributed workloads, it's adding support for something called barrier execution, which basically all it does, it gives control back to the cluster machines that you're using for you to run either OpenMP or TensorFlow distributed or why not. So don't expect to use this feature on your own. But like if you're advanced user or maybe ourselves will create extensions on top of these that makes use of this functionality. But if you had to use it, you basically use Spark apply, you say barrier equals true, and then what you get is, in this case, is just a single machine. You would get basically the IP addresses and the ports that you can use to directly communicate to those machines. All right, so we're going to switch to MLflow. And before we kind of like explain what MLflow is, I want to kind of like present what's the problem that MLflow is trying to solve. And for that, I want to use a quote from Andrej Karpathy, which leads the self-driving effort at Tesla. And in one of his talks, he mentions that, like the stack for software 2.0 doesn't exist. So what does that mean? So if you think of companies like, for instance, Netflix, right? They have a bunch of movies, and they need to do data science on those movies and to create a recommendation algorithm for you to, to choose a movie to watch. Companies like Apple with Siri, they need to, like do models around speech processing, and companies like Tesla need to capture images and then train deep learning models on top of them. So you're probably familiar with this. This is the standard kind of like data science approach where you get a data set and you create a model out of that. But then something that you can consider is also, well, if I already have this model, maybe I can make it part of my product. So things that Netflix does, for instance, is like they don't only create a recommendation model, but they deploy the recommendation model to their website, right? So you see the model being deployed there. If you're Apple and you're using Siri, you also have a model deployed on your phone. And if you're Tesla and you're building self-driverless cars, you also deploy that model to your cars. So now you have models in production. So what do we do? What do you do with those? Well, you usually want to collect data because there's a bunch of data that is meaningful to get either from your actual things that you're watching on Netflix or why not. And once you have the data, you kind of like want to tidy it because this data is usually pretty messy, and you bring it back to the beginning. And the problem that this creates is that you usually don't only have one model. You have multiple models. You have multiple parameters that you're using to train your models. You have multiple versions of the data, and you have multiple versions of the code. So it can be pretty easy to get into quite a mess while you're trying to, like do this faster and faster. So the MLflow project basically is an open source platform to manage the machine learning lifecycle, and you can use it from R as follows. It has three main features: MLflow tracking, MLflow projects, and MLflow models. Tracking basically tracks your parameters and your metrics. Projects allows you to deploy to production your models, and the modeling component of this project allows you to perform inference on the models. In this particular example, all we're using is the tracking component of MLflow. And like we're basically saying, start a new MLflow experiment, then we log some parameters and we log some metrics. So kind of like to put all this together, let's just take a quick look at how this all works together. And now it doesn't mean that you need to use Spark, MLflow, and Delta Lake together. You can use them separately, right? But in this particular demo, we're gonna basically use all of them at the same time. So first of all, we're defining some helper functions, and then we're connecting to Spark, and we're saying package equals Delta, which is the component that we mentioned is required when connecting to Spark. And then what we're gonna do is we're gonna download a data set with, that tracks wine quality. We're using the pins package for that. Then we're reading it as a CSV in Spark, and then we're writing it to Delta. Now, you usually wouldn't do this. You usually have a big data set already, but just for the purposes of this demo, this is what we're doing. So now the data is being written to Delta Lake, and then what we can do is we can use Spark to, first of all, log which is the version of our data that we're using. You can also log some of the parameters that we're going to be using in this case, using GLM on Spark. So we're logging the parameters that our model is using. And we're also logging the actual metrics. And you get that for free. It's automatic. And then you can use it. So suppose now that we didn't really like the performance of this model, and then it also happened to be the case that someone came along and replaced our data set, or new data became available. So we have two things changing. One is the actual data set, and we also change our model, and we're gonna rerun it. And again, this is mostly transparent. Once you start using MLflow, you're logging all these. But the great thing is that you can actually track these metrics by using the MLflow UI. And you can take a look at here, and we have two runs that we just performed. One of them has a lambda of 0.5, and it's using the version of Delta Lake 1 of the data frame. And then we also have our previous run. You can see here that you have things like some metrics, and then you can drill down and look at this particular experiment and open up and look at it and say like, wow, this is looking great. And so you can add a node, looking great. And you can also look at the metrics. Our particular run was pretty small, but if this was like a pretty long run, you could actually log the progress and see progress towards it. All right, so that covers kind of like everything else. And there's 2 more things that I want to share. So I know that there's a lot to learn about, in order to learn Spark and all these things in one 20-minute talk is impossible. So if you feel a little bit lost, don't worry, we have you covered. We wrote a book with O'Reilly, this book that you can just go and purchase. It's called Mastering Spark with R. It's on your favorite local store or online. And mostly it's a great resource for you to learn Spark. You can basically, if you don't know anything about Spark whatsoever, just grab the book and read it start to finish. If you're an intermediate user, that's also fine. You probably will find tips and tricks that you didn't know about. And if you don't feel like buying it, that's also completely okay. You can go to the rinspark.com, and it's free to use there for you. And last but not least, I want to kind of like give a big shout out of thank you to the R community. The Sparkly R project, honestly, is just successful because of the R community. And there has been a lot of momentum going on. There's over 20 community extensions created for the Sparkly R project, and there's over 50 contributors. But most interestingly, there has one thing that has changed on the last 3 months, is that while RStudio keeps being one of the main committers and supporters of the Sparkly R project, there's interest for other entities like Qubole and Databricks adding new features like Spark 3.0, which was provided by Databricks, and also a lot of good collaboration going on with the Ursa Labs project and Apache Arrow. So we definitely want to take Sparkly R to even grow broader with the R community and beyond the R community. So the other announcement that we have for today is that Sparkly R is joining the Linux Foundation under the LFAI umbrella. This basically doesn't change anything as a user, but as a contributor, it changes a lot because basically that means that it should be much easier to contribute. It's also hosted within the Linux Foundation, which provides open governance and holds some of the project assets. And other projects have trusted the Linux Foundation, like Kubernetes, Delta Lake, Node.js, Horovod, and even Linux itself. So if you want to learn more about it, go to our SASE URL, sparklyr.ai, and thank you.
Thanks for that great talk. We've got a number of questions on Slido. So how will MLflow interact with tidy models, the tidy models ecosystem?
Yeah, that's a great question. The reality right now is that MLflow is pretty bare bones, as you noticed. Like, you basically have to do everything on your own. You need to say MLflow log, so there's no interaction whatsoever. But it's definitely something on our radar that we would want to do so much better. So I'm sure we'll come up with something. But right now, you need to log manually the parameters.
Are the ML functions that run in a local Spark instance automatically multi-threaded? Or do we still need to use things like for each, mcapply, et cetera?
No, it's actually multi-threaded. So you can use Spark locally. And there might be some very few use cases for using Spark on a single instance on your local machine. But I honestly don't recommend it because Spark was designed to run on clusters. So yes, you might get some performance improvements in some cases, but that's not the main use case for Spark anyways. Yeah.
So this is an interesting question. Are there plans to make MLflow more enterprise-friendly with things like authentication, permissions, et cetera?
You should ask that question to Tarif if he's somewhere in here, but not to my knowledge. I know that Databricks has support for MLflow. So if you're a Databricks customer, it's quite easy to use MLflow on their platform. But if not, I think you'll have to hack something together, at least for now. Okay. Yeah. Thank you.